Error problems 4a and 4b. 4a is show that the integral from 1 to 9 of 1 over x minus 8 cubed dx diverges. To do this, we have to notice that 1 over x minus 8 cubed is undefined at x equals 8 and break it up at 8. So I'm going to write this as the integral from 1 to 8 of 1 over x minus 8 cubed plus the integral from 8 to 9 of 1 over x minus 8 cubed. You can work with either part of it, because in this particular problem, both parts do diverge. Let's pick this part. Actually, let's pick that part, because I did this part in the solutions I wrote. So we'll do that part. So I'm going to do the limit as a approaches 8 from the right of the integral from a to 9. And I'm going to write that as x minus 8 to the negative third dx. And we're approaching 8 from the right because we are between 8 and 9. So we're on the right side of 8 because we're between 8 and 9. Okay, we're going to write this as the limit. A goes to 8 from the right. I'm going to integrate this. I'm going to get x minus 8 to the negative second divided by negative 2 from a to 9. I'm going to rewrite that so it's easier to deal with. A goes to 8 from the right. I'm writing it as 1 over negative 2 times x minus 8 squared. Although in the notes I actually brought the negative up to the top. The 2 still has to be on the bottom, but the negative part can be on either the top or the bottom. Plugging in the limits of integration, get the limit as a goes to 8 from the right of negative 1 over 2 times 9 minus 8 squared. That's just going to be negative 1/2 minus negative 1 over 2 times a minus 8 squared. Okay, now here's what happens. This part's 1/2. I don't really care. A negative 1/2. But this part here is a goes to 8. 8 minus 8 is 0. And division by 0 blows up to infinity. This is a minus infinity. So we get a plus infinity. The other side is minus infinity. That means it diverges, right? If the limit is infinity, we get divergence. And that's all we can say. We can't say it diverges to infinity or to negative infinity. We can just say it diverges because this side goes to infinity, but the other piece actually goes to negative infinity. But if you've got more than one piece, once it diverges, just say it diverges and stop there. The other one, we want to show the integral from 1 to infinity of 1 over x plus 2 times x plus 3 is convergent, and what it converges to. So we know we're going to write this as the limit as b goes to infinity of, the integral from 1 to b of 1 over x plus 2 times x plus 3. And then we're going to get the limit as b goes to infinity of whatever the integral of that is, evaluated from 1 to b. But I actually want to do the integral indefinitely down here. So I'm going to do this integral as an indefinite integral by noticing that I have to use partial fractions. So I'm not going to do the limits of integration. Let's see, I'm going to do the integral of 1 over x plus 2 times x plus 3 dx by noting that 1 over x plus 2 times x plus 3 I can write as a over x plus 2 plus b over x plus 3. Multiply both sides by the common denominator. On the left you get 1. On the right you get a times x plus 2 plus b times x plus 3. Picking convenient values of x, like x equal to negative 2, you get 1 equal to a times 0 plus b times negative 2 plus 3 is 1. So I get b equal to 1. Picking b equal to 1. I feel like I made a small error here. Let me just make sure I'm not doing something really dumb. That should be b over x plus 2. Sorry, yeah. Okay, let's be a little bit careful. I have a over x plus 2 plus b over x plus 3. And sorry, I got those a little bit backwards. Apologies. A times x plus 3 plus b times x plus 2. So when x equals negative 2, you get a times negative 2 plus 1. So 1 equals a. And b times negative 2 plus 2, so b times 0. So a equals 1. Sorry about that. And then setting x equal to negative 3, you get 1 equal to a times 0 plus b times negative 3 plus 2 is b times negative 1. So negative 1 times b equals 1, so b equals 1 divided by negative 1 is negative 1. All right, so then we can write our integral as the integral of a over x plus 2 plus b over x plus 3. So I'm going to write minus 1 over x plus 3. And then we can integrate. So it's just going to be the natural log of the absolute value of x plus 2 minus the natural log of the absolute value of x plus 3. And in this case, it is important to simplify this as the natural log of the absolute value of x plus 2 divided by x plus 3. That's what we're going to have here. That's what our integral is. Now I'm going to drop the absolute values because both 1 and b are numbers that make the insides positive, so we don't have to worry about it being negative. So then that's going to be the limit as b goes to infinity of the natural log of b plus 2 over b plus 3 minus the natural log of 1 plus 2 over 1 plus 3. All right, now check this out. As b goes to infinity, b plus 2 over b plus 3 is going to go to 1, right? That's like a rational function. It's 1b to the first plus 2 over 1b to the first plus 3. Rational function, degree on top is the same as the degree on the bottom. So the limit of this part is the quotient of the leading coefficients, which is 1 over 1. This is going to be the natural log of 1 over 1 minus the natural log of 3/4. The natural log of 1 is 0. And you can write the negative natural log of 3/4 as the positive natural log of 4/3. That's not absolutely necessary, but it does feel more correct. That's it.